Hey, so now we will discuss about fractional numbers. Fractional numbers, that is fractional numbers. Okay, so suppose we have two letters. One is P, and the other one is Q. These are the two letters we have here. Now, if we write these two letters as P, a bar sign, then Q, we pronounce this whole thing as P by Q. Okay, in this form, if we write this P and Q in this form, and if Q doesn't equals to 0 and P doesn't equals to what? Sorry, if here if Q doesn't equals to 0 and Q doesn't equals to 1, so if these two conditions are made, okay, and if we put any values in P and Q other than 0 and 1, then we can say that that number is a fractional numbers. These are the fractional numbers. For example, so if we want to take any example, 1 by 3, so this is P here, this is P, and this is Q. So in P we're putting 1 and in Q we're putting 3. Is the 3 here is equals to 0? No, it is not equals to 0. Is it equals to 1? No, it's not equals to 1. So you can say that this is a fractional number. Now in fractional numbers we have proper number and improper fractions and improper fractions. So proper fractions, and what? Improper fractions. So in case of simple fraction, that is proper fraction, so for proper fraction, P will be less than Q. That means we have here P by Q. Okay, so here the value of P will be less than the value of Q. For the one of this example is 1 by 3. So this is a proper fractions. So again 2 by 4 is also proper fractions. 5 by 7 is also a proper fraction. Why these are proper fractions? Because the value of P here is less than the value of Q. The value of Q is greater here. Okay, in case of improper fractions, the vice versa occurs. Vice versa, how vice versa occurs? That is, in case of improper fractions, if we write 4 by 2, then we can say that this is improper fraction. Why? Because here P is greater than Q. Understand? P is greater than Q. So we have here 4 by 2, that is, we can write 2 by 1. But this is not a improper fractions. Why? This is not a fraction. We cannot say that this is a fraction. Why we cannot say this is a fraction? Because our condition was Q not equals to 1 and Q not equals to 0. If Q not equals to 1 and Q not equals to 0, then 2 by 1 is not a fractional number. So suppose 4 by 3. Okay, In case of 4 by 3, what we can say for this case? 4 by 3 is what? 4 by 3 is, yes, this is an improper fraction. Improper fraction. Yes, this is an improper fraction. Now let's talk about rational numbers. Have you ever heard the name of rational numbers? Let's talk about rational numbers. Okay, rational numbers. So what are rational numbers? So numbers, if we have the form p by q, if we write anything in the form of p by q, so that will be a rational numbers till q is not equals to 0. That means if q equals to 0, that number won't be a rational number. But if q is not equals to 0, then that number will be a rational number. And if it's expressed in p by q form, so in that way we can say that that's a rational number. For example, we can say examples here. Set some examples. What are some of the examples we can set here? That is 3 by 1. In 3 by 1 we have here 3, and in below in q the value of q is 1, so it's 3. You can write it's 3, and it's what? It's a rational number. Why? Because q is not equals to 0. Q is not equals to 0 here. Again, if you write so 11 by 2, okay, the result will be 5.5, something like this. This is also rational numbers because it's expressed in p by q form, and this 2 here we have 2 below, okay, and 11 in above. So these are the rational numbers. That is, numbers of the form p by q are called rational numbers when p and q are what? Are integers, and q not equals to 0. That means another condition is p and q, these should be integers. They should be what? Integers. Yes, that's right, they should be integers. And I think we can know that another example will be 5 by 3. Okay, that is 1.66666 dot 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 dot. So any rational numbers can be expressed as the ratio of two mutually prime number. This is also another information that if we have any rational number, this can be expressed as two mutually prime numbers. So all integers and fractions are what? Rational numbers. Another thing that is very important, all integers and prime numbers are rational number. So all integers and prime numbers are rational numbers. We know what integers are. So from minus infinity, plus infinity, and all the whole types of numbers, that is minus 3 plus 1 0 with this 0. And prime numbers, we know what prime numbers are. That is 1 3 so we also know what prime numbers are. That is 3 5 2 1. These are the prime numbers. That means the number that is divided by 1 and itself. Okay, that can be divided by 1 and itself. These are also, there is 2 3 5 7 11. These are what? Prime numbers. So